Mhm.
Right. So to continue, we have we were discussing TCP numbers, TCP sequence numbers, and acknowledgement numbers, and I was saying, um, when we talk of TCP, we talk of reliability. Reliability means knowing information has been sent or hasn't been sent. How do devices know kuti information yasendwa kana kuti haina? They make use of what we call a sequence number. So sequence number is basically a number which indicates the first byte of a segment. S- Let's say first byte information yako yese rida kusendwa. So let's say for example, ndoda kusenda information. Ndoda kusenda information yangu ine 1000 bytes. Yet not we have what we call the initial sequence number. So patiri kutangira. So if we say we are starting at number one, that is our initial sequence number, which tells us kuti ndo position yatatangira. Then if we send 1000 bytes, then it means at 1001 tinenge takufanira send another information, probably another 1000. So the sequence number at that point kana tauda send another 1000 bytes inenge yapa 1001. Then what happens patinenge tiri pa 1001 apa, there is an acknowledgement inosendwa inenge ine this number ish 1001. Am I putting this correctly or clearly? Let me put it this way. How do I delete this? Just a minute. Let me see. How do I clear this? All right, eraser. We have this. All right, sequence number ndo patiri kutangira. Yeah, sequence number ndo patiri kutangira. Let me see. So let's say our initial sequence number is 1. So tiri kusenda 1000 bytes every time, uh, from PC1 to PC2. Right. So panosendwa first 1000 bytes, 1000 rasvika uko. Kunoku rinosvika pane sequence number 1001. Then if PCE sends back this number kunoku, ndiyo inonzi acknowledgement number. PC ikareceive 1001, it means we have successfully sent 1000 bytes. That's basically the idea behind sequence numbers and acknowledgements. So if I start at 1001 and I send another 1000 bytes, it means kunoko sequence number inosvika 2001. Then if PC2 sends this number 2001 to PC1, that's acknowledging that I have received 1000 bytes. However, if sequence number ikatanga iri pa 1001 kunoko, then kunoko device iri rosenda 1001 back, it means nothing has been received upon information I received. So in basic terms, that's how my sequence numbers and my acknowledgement numbers work. So it's sort of an accumulation of those numbers up until communication area pair. Pakangoitika a missing number, it means information here inosendwa. Then a retransmission iri kutangira at that point. So ipapapa in this example, retransmission yedu ndikasenda from sequence number 1001 kunoko acknowledgement yodzoka ine 1001, but I'm expecting kuti acknowledgement idzoke ine 2001 because I'm sending 1000 bytes. Then it means nothing has been sent. Then it means I will need to retransmit these 1000 bytes. So that's the idea behind my sequence numbers and my acknowledgement numbers. It basically allows kuti pasawane packet risina kusendwa because my numbers are they accumulate kubva pana 1 unoenda pana 2 unoenda pana 3. 2 akangoita missing, panodzokwa acknowledgement inodzoka ichitangira pana 2. Then we know kuti 2 haana kusendwa, we have to resend segment, or byte number 2. And that's how sequence numbers and acknowledgement numbers basically works. So with that, that's how a protocol like TCP ensures your node reliability. making use of those sequence and acknowledgement numbers. TCP window sliding mechanism. That one is used to control uh, data transmission, right? So if if I'm trying to send information from a PC, like here, from PC1 to PC2, and probably network yedu along the way, network yedu yakadhakwa is congested. Network yedu kana yakadhakwa, isusu tikaramba tichipusha a lot of information from this end, information iyo haisvike this end, because network yedu kana yakadhakwa, probably it's dropping my packets because it's congested. Or rate of transmission from this PC kana yakawandisa way above rate of information being received on this end, then it basically means some of information will get dropped because PC2 cannot handle all the traffic of PC1. There is need to have a way of controlling that. So initially, per network communication, there's an exchange network between this PC and PC1 and PC2. Per network three-way handshake that we just mentioned. Per network synchronization acknowledgement, then another acknowledgement, that three-way handshake. There is what you call a window size, send off from PC2. Window size is PC2 basically saying, inini, at this point, I'm able to process 1000 bytes. Therefore, can a PC1 send the information, send 1000 bytes, and it waits for an acknowledgement after sending those 1000 bytes. So window size, it basically tells the sending device quickly, this is what I'm capable of processing at the moment. Kana probably transmission yedu iri proper, hapana congestion kuitika, link redu riri fine, maybe window size can increase. Easy, I can take in 2000 because the link redu riri perform. That's the window size. So it's communication between my PCs. But this sliding mechanism usually works kana paitika something. Link redu ranga rushanda, but now it's getting congested. So this PC will need to tell PC1 to slow down. So reduce this window size, let's say reduce to 500. Then it tells PC1 to window size redu, it needs to be reduced so that we can be able to process and manage the transmission rate from the sending device. That is basically the idea behind the window sliding mechanism. Say it leads up to reliable transmission because the kind of data transmission is really high, rate is actually high, but receiving end, we are not taking in all that information at that specific rate. My packets are not going to drop. The more packets are being dropped, that's not a reliable transmission. Therefore, window sliding mechanism, it leads to a reliable transmission. That's basically the idea behind the window sliding mechanism. Then shut down the four-way handshake. That's session termination. Tapeza communication. Pekutanga pangachidotanga communication with the three-way handshake. That's sort of hello. I want to communicate with you. Okay, got to communicate. Then kanta communicator. Toita communication yedu. Kana tapeza, we close that session. Wapedza kusenda ere ine ndapedza kusenda, okay, bye bye, ndapedza tese kusenda. That's what the four-way handshake is. So there is a message which is sent, finish, it'll pay up. This one, sending device send a fin, yet not a fin, fin, saying I finished transmission yang. Then this one sends an acknowledgement, the receiving device, that's to sends an acknowledgement saying ndazvinzwa kuti iwo wapedza. Then kana iyo PC2 yapedza yosendawo its finishing flag saying inini wandapedza. Then this one acknowledges kuti device 2 has finished the transmission. If we acknowledge kuti tese tapedza, that's how a session is terminated. If one end acknowledges, the other does not acknowledge, then it means hatisati tapedza kusenda. All leads to a reliable transmission. That is basically what TCP, three-way handshake, window sliding mechanism, four-way shutdown, that's how it's working. Network layer, this one, like I said, is responsible for IP addressing, the open network routing. The transport layer is responsible for establishing connections. The network layer is responsible for transmitting data from one host to another. So apa ndo panaitika transmission, not transmission as it is, but the logical connections, IP addressing, finding the best way to get to the destination. That is where it happens here. So that is where we have all my routing protocols edu. That is where we have our OSPFs. I think this is one of the most common on our RIPs, EIG, RIP. These are some of the protocols that I use at this layer. That's where we have my protocols, like I say, IP version 4, IP version 6, ICMP, some protocols that they used at this network layer to make sure we have the best route to the destination network. Working process of a network layer. So the network layer, it makes use of, yeah, it's not a routing table. It makes use of a routing table to see the destination network in papi. So in this example, probably let's look at router 1. Pane loads of routes in the panel. Okay, let's look at router 1. No, let's look at this router. So I want to take a look at this router. And do not send the information from PC1 to PC2. At layer 3, what happens? Number 1, IP addressing. My devices I have my IP address, which I identify as my network. That happens at the network layer. That's one. Then when it comes to the routing part, we will need to find the best way, best path from the source to the destination. I can either go via this direction, ndinosvika ku PC2, or I can go via direction iri highlighted this one, ndinosvika ku PC2. So how does this router, actually it's not this one, is this router Rupe from I think it's explainable in finding the best route. How does my routers Edu find the best route? So my routers Edu, they have a routing table. A routing table, it basically displays my networks which are known to the router. So ndikayapa example yangu, this router, I want to click. All right, is raise or icon slice. Right. So ndikayapa router rangu rinori, there is a display per routing table yekuti what is the network iri panapa and what is the network iri panapa. So routing table ipa R1 apa inenge ne network iri kuside kuna G00 interface, then this side harina kui, let's put it G002 interface. So let's harina kuiswa apa G002 interface, but let's put one ourselves. So routing table, it tells us ku network G00 kune network yakati, ku G001 002 kune network yakati, ku G001 exo G001 kune network yakati. That is what the routing table tells us. Saka information kana ichibva kunoko ichida kuenda kunoko, painosvika parouter inotarisa routing table. Routing table ndio inoudza kuti network yauri kuda kuenda iri papi. Panapa pane just one pathway, so information it gets led to router 1. But from router 1 pane mapathways akawanda. So router 1 will decide depending on a number of parameters kuti pathway iri proper kuenda nayo ndeipi. So information yangu yasvika parouter 1, right? Information yanga shika pa router 1, we now have to choose which path do we have to take. Tinoendera kutarisa routing table. Routing table inenge ine maroutes ese aripo. Maroutes iya ane atinoti macost. So inotarisa cost iri cheaper, iri lower. That is what we call a preferred route. So in a cost inenge iri lower, in this example, inenge ine cost iri lower ish. So that's the route which is being chosen to get to the destination. As much as route ina G00 iyi ichitisvitsa to the destination as well, it's not chosen because it's not a preferred, it's not a preferred route. So that is the process of the network layer, choosing kuti route preferred Russian nderipi, route richaiswa routing table Russian nderipi. How are we going to get there? That is what the working process of the network layer. Essentially, it's a bit simplified, but I think as we go, particularly IP addressing, subnetting, probably routing, I think no particular tips about my processes. Data link layer. This one is we mentioned data framing, local addressing, physical addressing. This is where framing basically happens. We have a number of protocols that are very common on Shanscom. Ethernet, I think this is the most common, and this is the one we mostly use. We also have point-to-point over Ethernet and point-to-point itself. Some of the protocols, the repo, I think we'll learn about them as we go with the course. For now, data link, that's where framing happens. That is where MAC addressing happens. What else? Nothing much here. Ethernet definition, broadcast domain corresponds to an IP network. Right. I think it's very important understanding the difference between my MAC addresses and my IP addresses. Maybe let me use this example. Right, let me use this example. Probably I can add another network here. Right. So from perspective here, router yangu node, we have what we call my broadcast domains. A broadcast domain, a domain where in a network, if I send a broadcast, then every device in that domain will receive the message. So in this example here, this is a broadcast domain. Why? Because if I send a broadcast from host A, for example, host B, host C, host D, host switch A, switch B, everything in the domain will receive that device. So router redo is sort of the device which breaks my broadcast domains. So in broadcast domain 1, another network broadcast domain 2. A router is responsible for separating my broadcast domains. Right. Then we have what we call my collision domains. My collision domains is more to do with the layer 2 device in this case. Right. Collision domain is a domain, a good if I'm trying to send information to any device in the network, then every other device will listen to that message. So collision domain is best explained in internal bus topology, where we have a shared medium. So if I'm trying to send information to B, for example, the moment I trace a packet to line if, then I'm forced, C is forced to listen to that packet. That is what we call a collision domain. A device right now, the switch a layer 2 device, making use of my MAC addresses, it separates my collision domains. So instead of having A, B in the same collision domain, switch rename ports. So port, let's call this port 1, let's call this port 2, let's call this port 3. Rename my ports were they used to separate my domains. How do they separate my domains? Every port, rene a different MAC address from the other, meaning a separate collision domain. So my MAC addresses, they are related to my layer 2 devices, they are related to my collision domains, my IP addresses, layer 3 devices, broadcast domains. If I'm trying to send information locally, I use my MAC addresses. If I'm trying to send information remotely, I have to make use of my IP addresses. So it's very important understanding the difference between layer 2 and layer 3 addresses, IP and MAC address. ARP, this one is a protocol which is used to map between my IP addresses and my MAC addresses. Let me see, how do I put this one? This is zoom in, zoom out. Right. Let's say we have a network. This is how ARP works. Let's say we have a network like this. So we have device A here, we have device B. Let's say device B here, let's call this C. Right, can I send the information? If I'm sending information from A to B, that is local communication. It means I can make use of my IP addresses. If I assume that my MAC address is a local IP address, local MAC address, I mean, then remote IP. Let me not confuse this. Right. So here, this is local communication E. If I assume could my MAC addresses angle is A, B, C for my devices angle, and I also assume could my IP addresses is 1, 2, 3. If I'm sending locally, destination MAC address angle is the address of the destination device. So in this example, ndikati destination MAC, not source MAC panel. For these two scenarios, here local, A to B, destination yangu is B, B, and source yangu is A. Very easy to see. Destination IP yangu is 1, source is 2. Very easy to see. Kana ndakusenda remote, however, let's talk of destination MAC, source MAC. Kana ndakusenda, for example, from A to C. That's remote. Why remote? Because takusenda within from one network to another, E network ish within its own, E network ish within its own. That's remote. So if I'm sending from A to C, you realize with the destination mark yangu haichazi C, even if destination device yangu is C. The reason for that being my MAC addresses, my local addresses. So currently papa source pangu panapa pa A MAC address haibude network. So you realize that the destination yedu ishatora the MAC address of yatinoti gateway, the way out of the network. So address panapa, if we call it E, ndio address inenge iri pa destination pedu panapa. Kana information ichibva pa A panapa ichida kuenda ku C. Right. Kana tasvika on the other end, kuti tizosvika kuno uku, tinenge takushandisa ma IP now. So my IP yedu, source yedu is A, that's 1. Destination yedu is C, that's 3. My IP address allows remote communication. So kana ndiri communicator from A to C, it's mostly my IP address ari kushanda pa remote connection iyo. So MAC address yangu yagumira panapa, IP address inobva yasimudzira yobva yasvitsa information ku network inoyi, yasvitsa information to the other network. There will be need yekuziva kuti the physical address, the local address ichi, ndo panopinda protocol inonzi ARP. Because tasvika another analog probability based explain this. Right. two manetworks ai Harare Bulawayo. MAC address haibude muHarare umu. I-local address inotambira muHarare imomo. Kunoko MAC address yekunoku haibude muBulawayo inotambira imomo. However, IP address inobuda muHarare yoenda kupi? KuBulawayo. So if I'm trying to communicate between my remote networks Harare and Bulawayo, ndinoziva kuti locally ndabva kupi using the MAC address. Then kana ndakubuda ndoziva kuti remotely ndikuenda kuBulawayo using IP address. However, kana ndasvika pagate reBulawayo kuti ndakupinda muBulawayo, there is need of knowing kuti locally pandiri kuenda chaipo ndepapi. So there is need of knowing the MAC address. That process of knowing kuti chaipo chaipo panoda kuenda ndepapi, that process of knowing the MAC address, it uses yet not the address resolution protocol. So how does it work? There is a cache inenge iripo, a table. Let's say a table inenge yakanzi IP address yakati is mapped to MAC address yakati. So every time pandinosvika kuBulawayo, there is a directory riripo rakanyorwa kunzi kana IP address yako yakanzi chakati, zvirova riri kuenda kutown kuka small town kakanzi chakati kuBulawayo, ndio inonzi ARP. So it maps my IP addresses edu ne MAC addresses. I think you can see it from here. We have a destination IP, but we don't have a MAC address. So how do we find that destination MAC address? We make use of the address resolution protocol. In some of those protocols, I think that you need to know along the way. Very important, understanding the ARP protocol and its implementation. Right, implementation, I think we've talked of the table. Table yedu ndoye nema mappings ese IP address nema MAC address. Then kana mutable musina chinhu, there is a request which is sent, a broadcast. A broadcast inosendwa kuBulawayo kuti nini ndine IP address yetown yakanzi chakati. Town yacho handizivi kuti iri papi. Then matown ese respond. In fact, town ine IP address iripo ndiyo inoresponda kuti inini ndiri pakati. Then that's how you know kuti MAC address yakati ne IP address yakati they correspond. Kana taziva yobva yaiswa mutable. So that next time patinouya, you don't have to ask. Our time is moving. Right, that's ARP for you. I'm assuming my job is probably to give you a little bit of light. Mungachienda unozoverenga theory, I think you get to grasp with what exactly are we saying. Physical layer transmission is telecommunications networking students. I don't think we have to explain a lot here. That's where data transmission happens. That's where you have your media. That's where you have your copper, your fiber, your wireless, whatever it is. That's where you have your connectors. And basically, that's the physical layer. Common transmission media, fiber, twisted pair, UTP, STP, coaxial cable, serial cables, connectors, RJ45, LC, SC, fiber. That's basically the physical layer. I think everyone, because you're doing telecommunications, you're doing networking, we don't have to go deep into the type of media that we use. Then encapsulation, de-encapsulation, encapsulation, adding headers. I think Tambotaura this word. When you talk of encapsulation, think of adding headers and trailers. So information you can go from the upper layers application. Inenge kushandisa PD runs data. This one, protocol data unit. Then kana yakudzika down the layers. Ikasvika transport layer. Inenge ederwa a trailer and a header. Data radio. Rino ederwa header and a trailer. That process means encapsulation. Ederwa header and a trailer. Ringe ram segment. Ram layer 4. Then kuti ripinde layer 3. Rino ederwa a header in a segment as well. A header and a trailer as well. Rover packet. So every time parikubva from one layer to another, there's extra information irikuiswa. Adding that extra information ndio inonzi encapsulation. Extra information iyo inenge ine chi we've mentioned issues to do with port numbers per layer 4. Ndo extra information. Kanti apa layer 3 takuedera ma-IP addresses, ndo extra information. Panapa takumedera ma-MAC addresses, ndo extra information. So that's the process of encapsulation as we move down the layers. Then kana takudzokera, moving up ma layers edu, takutora zve-de-encapsulation. So takuremova ma-headers nema-trailers. So ndakuremova, ndichitangura panapa, ndakuremova header repaframe ndobva ndatarisa kuti MAC address ichi. If it corresponds to the device receiver, then it goes up, yotarisa IP address, yoremover, yotarisa IP, yoremover, yotarisa ma-port numbers. If everything is corresponding up until we get to see the message yasendwa yacho. So that is the process of de-encapsulation and encapsulation. So I think take note of de-encapsulation. This is the receiving device, web server, client, or on the other end. So if you are sending application, encapsulation, up you get to the physical layer. Receiving, physical layer going up, de-encapsulation. What else? I think basically that's it. In summary, we have discussed the OSI model, TCP, IP reference model. We have basically gone through 7 layers and what each layer is responsible for, how do protocols interact when we are sending information, tapping a little bit deep into each and every layer, probably mostly per transport, I think, in Dora Dada Utipisa. We discussed issues to do with TCP handshake, three-way handshake, which basically is used to establish a connection. Then on the other end, the connection here, we have the four-way handshake, which terminates that session. We have a window sliding mechanism, which allows controlling the transmission rate so that we don't lose information. The whole idea having a reliable communication. And basically that's it for we. What are the benefits of the layered model? What are the common protocols at the application layer, transport layer, network layer, data link layer? If you have any questions, this is the time. I think we have 5 minutes. Also, to pay my answers for the quiz, Iriboy. Either of those two. What are the benefits of the layered model? I don't think we discussed that, but that's very important. Pay my answer, no. Zembe, Kelvin, Chiwoto, Mambandiani, Mkazi, Zoom user. Unmute yourselves. I need answers. Passamon, what are the benefits of layered models? Farai wakaita CCNA, Helena wakaita CCNA, you know the answer to that. DPO answer. Sudobure. Yes, Farai, I can see you've unmuted. TP answer. What are the benefits of layered models? Okay, you can answer my exam, not an issue. Any questions before I close the session? Any comments? Nothing? Okay, proper. I think with that, we can end session redo chapter 2. Hopefully over the week we'll get to catch up with schedule. Thank you very much for attending session. Have a good evening. Good night.